Okay, so there's different ways of simplifying. You could use a factor tree, or you could use perfect square numbers. It's totally up to you. I'm going to compare a couple of them. Let's use the factor tree with 24, the square root of 24. So 24 breaks down to, you could say, 2 times 12. 12 breaks down to 2 times 6, and then 6 breaks down to 2 times 3. Okay, so keep in mind that everything that pairs up will be on the outside of the root. Anything that doesn't pair up is going to stay on the inside of the root. So I have 1, 2 right here, and another 2. That pairs up, that's one single 2 on the outside. Now, does this 2 pair up with anything? No. Does that 3 pair up with anything? No. So I really have a 2 times 3 on the inside. So my final answer will be 2 square root of 6. That's my final answer. Now, that's the factoring method, the factor tree method, or you could do what I first taught you. 24 is not a perfect square number. Rewrite it with multiplication to get a perfect square number. That would be 4 times 6. And then you could split the root, and you'll get your final answer, 2 square root of 6. Same thing, just depends what you feel more comfortable with. If you're not good with thinking of perfect square numbers, then go for the factor tree method. Okay? But remember, it has to be items that pair up is what comes out to the outside. Whatever doesn't pair up stays on the inside. So, number 2, the square root of 60. Do you guys want to use perfect square numbers? Or do you guys want to just factor with the factor tree? Pick one. Okay, so if we're looking for perfect square numbers, I believe 4 times 15 is 60, right? Now, let's say you really like the perfect square number method, but let's say like right now you just said, I don't see the perfect square number that works. Well, if you don't see the perfect square number that works, just break it down and use a factor tree if you don't see it right off the bat. So we already said 4 times 15 works, but let's say you didn't see that. Factor tree, 6 times 10, 2 times 3, 2 times 5, right? What pairs up? The 2's pair up, so there's one single 2 on the outside. What didn't pair up? The 3 and the 5, so 3 times 5 is 15 on the inside. So you get the answer 2 square root of 15. Now, if you saw the perfect square number and said, okay, 60 is not a perfect square number, 4 times 15 is, split the root, 2 square root of 15 is your answer. That's great. So those are both different methods, whichever you feel more comfortable with. And I like thinking of perfect square numbers, but if I don't see it right off the bat, I just start breaking it down to whatever. 6 and 10, and then break it down, and then pair it up and use a factor tree. So it's good to know both. Let's take a look at number 3, 108. What is a perfect square number that would work? 9 will work, but there's a better perfect square number. Even better than 9, better than 16, 36. Now, you guys are able to use calculators. All you got to do is take the 108 and divide it by one of those perfect square numbers. Try to divide by 49, it's not going to work. Try to divide by 36, it'll work. It'll be 3. So if you go if you go 36 times 3 and then split the root, 6 square root of 3 is your answer. You're done. Okay? Now, number 4. I like number 4 because there's so many possibilities. There's so many roads to the same place. So many different ways of doing this problem. Okay, so one method is to break down whatever you could break down. Like the square root of 8 is not a perfect square number. You could rewrite it as what? 4 times 2. And then you could split the root. And you'll have 2 square root of 2. But then you have times the square root of 6 that you couldn't break down, right? So then you could actually multiply the radicals, square root of 2 times square root of 6. And what do we get? So you have 2 square root of 12, right? So you really have 2 times, and let's break down 12 to 4 times 3 and split the root. So I really have 2 times 2 square root of 3, which means that my final answer is 4 square root of 3. Is that the best method? Probably not. So I could have, right from the start, said, I'm going to put these radicals together underneath one radical. What's 6 times 8? 48. It's 48. So I could have rewritten it as a square root of 48 and then simplified the square root of 48 thinking of perfect square numbers. Like, what times what is 48? 12 times 4. That'd be breaking it down with the factor tree, but let's go with perfect square numbers. 16 times 3, split it, you get 4, square root of 3, same answer. Right? Yeah. Let me show you yet a different way. And let me use the factor tree method. Check this out. I am going to just break down everything. 8 could be rewritten as what? 4 times 2. And then 4 could be rewritten as what? 2 times 2. Yay? Now, how about that, the 6? What could I break that down to? Break that down to 2 times 3, right? So I just broke everything down as much as I possibly could. And now let's look at what we have, and let's remember that what pairs up goes on the outside, whatever doesn't pair up goes on the inside. So I have a pair of 2s right here, don't I? So I want to put that 2 on the outside. And then I also have this 2 right here and this 2 over here. So that's another pair of 2s that I'm going to put on the outside as one single 2. What's left over? The 3 is what's left over. So the 3 goes on the inside. So the answer is 4 square root of 3. Got it? So factor tree is pretty cool right here also. You just factor everything as much as you can. You break it down, and then you pair up and you take out. So whatever you pair up goes on the outside of the radical. Whatever does not pair up goes on the inside of the radical. Let's try another one of these. Now it's totally up to you guys whether you want to break this down to something, or whether you want to use a factor tree, or whether you want to multiply them together and then try to factor. It's totally up to you. So what do you guys say? You guys want to do factor tree, break everything down as much as you can? Okay, let's do both. 7. What does that break down to? That's just 7. It doesn't break down to anything, right? How about 14? What does that break down to? 7 times 2. So we factored everything that we could do, we factored it. So what paired up? And what stayed in? Done. Sometimes the factor tree is better, faster. Now let's say I would have gone the other route. 7 times 14 with the calculator is 98. Okay. And then I'd have to think about the perfect square numbers I could rewrite 98 to. Like 36, nope, 49. 49 times 2. And then you split it, and you'll get 7 square root of 2, same answer. So it just depends what you feel more comfortable with. Or you could have actually taken the square root of 98 and used the factor tree on the square root of 98. But I think breaking it down as much as you can right from the start with factor tree, it's the easiest in this case. Let's jump to number 6. What do you say? Factor tree?
First, try to combine like terms.
How about 3 times 5? That's 15. Done. So we don't need to deal with 3. We don't need to deal with 5 anymore. It's already 15.
48.
Okay, so let's remember we're going to have to multiply by 15, whatever we get. 12 times 6 and get 72, and then worry about getting the square root of 72, which is not that bad. That would break down to 36 times 2, or you could use a factor tree. Which method do you guys want to use? Factor tree? 12 breaks down to 4 times 3, right? 4 breaks down to 2 times 2, right? 6 breaks down to 2 times 3, right? So pair up. There's a pair of 2s, so there's going to be a 2 on the outside. And there's a pair of 3s, so a 3 is going to be on the outside. What's left over on the inside? This single 2. And let's not forget about the 15. So we have 15 times 2 times 3. 15 times 2 is 30. 30 times 3 is 90. Final answer is 90 square root of 2. Now, of course, we could have said 12 times 6 is 72. And the square root of 72 would break down to 36 times 2. And you'd get 6 square root of 2. But you still had that 15 that you need to multiply by 6. And that would still give you the same answer, 90 square root of 2. And number 7. Number 7, I would multiply 4 times 3 and get 12. And then I would take the square root of 3 and I would rewrite 18 using the factor tree as the square root of 3 times the square root of 6. Now, I'm going to even stop right there. I'm not even going to break down 6 any further, because the square root of 3 times the square root of 3, that's just 3. So I really have 12 times 3 times the square root of 6. So that's really 36 square root of 6. That's your final answer for that one. Let's all take a look at number 8. So I would rewrite 27. It's not a perfect square number. I would rewrite it as 9 times 3. And the t, you're just going to leave it in there. The u to the third, you could actually rewrite that as u to the second and then u. U to the second times u, because u to the second times u is u to the third. So all I've done is rewritten things inside the root to make it look nicer. No, not to make it look nicer, but to be able to actually take the square root of some things and get nice answers on the outside. So when I do split it, what will I be able to take the square root of? The 9, the 3, the t, the u squared, or the u? What could I take the actual square root of? The 9 and the u to the second. So let me do that. Let me take the square root of 9 and the square root of u to the second, and then the rest I'm just going to leave it in there, which is going to be a 3, t, and a u. So what is the square root of 9? The square root of 9 is 3. What's the square root of u squared? That's just u. And the square root of 3tu, we're going to leave it. And there's your answer for number 8. Of course, there's many, many different ways of doing this. Let's move on to number 9. Okay, so 50 is not a perfect square number. What I want to do is rewrite things so I could actually take the square root of certain things. So instead of 50, I'm going to say 25 times 2, because I will be able to take the square root of 25. And then instead of p to the 5th, I'm going to say p to the 4th times p. Are you with me? Okay? Now, what I want to do is split the square root only to the ones that I could actually do. So I could actually do the square root of 25, and I could actually do the square root of p to the 4th. So let me do that. Square root of 25, square root of p to the 4th. Now everything else I'm just going to leave on the inside. I want to leave the 2 and the p on the inside. So my final answer will be 5 p to the second square root of 2p. Yeah. So right here on number 10, we could start splitting roots, and I would rewrite everything on the inside so you could actually take the square root of some stuff. So like 108, it's not a perfect square number. What could you rewrite 108 as? 36 times 3. And the x to the 6th, I'm going to leave it like that because I am able to do the square root of x to the 6th. I am able to do the square root of y to the 4th, but the z to the 5th, that I can't really do it. I'm going to rewrite it. I'm going to rewrite it as z to the 4th times z. Does that make sense? Yeah. Okay, so out of everything that's on the inside, whatever works out nicely, I'm going to take the square root of. So I'm going to do the square root of 36. I'm going to do, so I already did that one. I'm going to do the square root of this guy, square root of x to the 6th. I will do the square root of y to the fourth. I will do the square root of z to the fourth. Z to the fourth. And I will do, and the rest, I'm just going to leave it in the square root. So what's the rest? It's the 3 and the z. I'm going to leave it in there, 3z. The answer here, the square root of 36 is 6. The square root of x to the 6 is half of that, x to the third. Y to the second, z to the second, square root of 3z at the very end. So on number 11, if you want, you could break up the square root to each of the terms and then simplify each of the square roots. Or you could start getting it ready to take the square root. So you could just rewrite the whole thing, but instead of 56, 56 is not a perfect square number. What could we rewrite 56 as? 4 times 14 is 56. So you could rewrite it as 4 times 14. And the m squared is ready to take the square root of that. So we put the m squared in there. The n to the fourth is also ready. But the p to the fifth, that one we have to actually modify. So that's going to actually be p to the fourth times p. The square root of whatever I can actually take the square root of, like 4. Square root of 4, that's going to be 2. Also, m squared, that's going to be just m when I take the square root of it. But I'm also going to do n to the fourth and also this p to the fourth. So I'm doing all the square roots that I could actually do. Now, whatever is left over, I can't do the square root of. Like I can't do the square root of 14, and I can't do the square root of p. So I'm just going to leave those in the root, 14p. Now, let's go in and actually finish this problem. The square root of 4 in front, that is 2. The square root of m squared, that's just m. The square root of n to the fourth, that's just n squared. And also p squared. And the square root of 14p, we're just going to leave it. So that is your final answer. Could you have done it differently? Absolutely. You could have broken up all the roots right from the start if you wanted to. Number 12, a lot of people get thrown off with number 12. Remember, you could use rules backwards. We had these reminders on the wall, and right here we have the square root of a times b. You could split the square root to the a and to the b. Same thing here, you have the square root of a divided by b. You could split the root to the a and to the b. But likewise, you could take the square root of a over the square root of b and go backwards and put them together. Now, I know you guys are thinking, that's kind of weird, but check it out. Looking at number 12, we're going to put them back together and put the 8 over 6 together. That way I could reduce 8 over 6. What does 8 over 6 reduce down to? 4 over 3. And then you could split the root again. So when I split the root, it'll be the square root of 4 over the square root of 3. And the square root of 4, that's just a nice, beautiful number 2. But the square root of 3, you need to get rid of that. You can't leave a radical in the denominator. So what do I need to multiply by? 3. That exact square root of 3 value. Square root of 3 here, square root of 3 up there. So your final answer will be 2 square root of 3 over 3. To number 13. Right here, you could actually reduce 2 over 10. If you reduce 2 over 10, it'll become 1 over 5. And now that you have 1 over 5, you could split the root. So you have the square root of 1 over the square root of 5. And what is the square root of 1? That's simply 1. And the square root of 5, you can't do anything with it, but you can't leave it in the denominator. So you're going to multiply both top and bottom by what? The square root of 5. So when you multiply both top and bottom by the square root of 5, you'll get your final answer, the square root of 5 over 5. That's your final answer for number 13. 14. You cannot simplify that root, so let's split the root. When you split the root, you're going to get the square root of 5 over the square root of 32. The square root of 5 you can't do, but the square root of 32, you could break that down to 16 times 2, right? And when you split those roots, you're going to end up with a new denominator. That new denominator will be 4 square root of 2, and the square root of 5 is still up on top. Now, again, you cannot leave a radical in the denominator, so you don't want this square root of 2, so what do? Multiply both top and bottom by what?
2.
By the square root of 2. So if you multiply top and bottom by the square root of 2, your final answer, well, so far, will be the square root of 5 times square root of 2, that is the square root of 10. And on the bottom, 4 times the square root of 2 times the square root of 2, that's really going to be 4 times 2. Because the square root of 2 times square root of 2 is just 2. So now we have our final answer here, the square root of 10 over 8. That is our final answer for number 14. So right here we're going to put both radicals together. So we're going to make the 3/4 times 4/5 be inside one radical. Now why would I do that? Because I could multiply 3 times 4 and get 12, and 4 times 5 and get 20, and then reduce 12 over 20 to 3/5. Or the easier way to do it is to cancel out the 4 and the 4, and you'll get the square root of 3 over 5. Now, of course, we have a fraction. We're going to split that fraction. It'll be the square root of 3 over the square root of 5. That's our answer so far. However, we cannot leave a radical in the denominator, so we are going to have to multiply by that exact radical value, square root of 5, on both top and bottom. And on the bottom, you will get just 5. And up on top, to make it look nicer, put both of these together. 3 times 5 is 15, and it will be inside the root. So your final answer is the square root of 15 over 5. Number 16, also, if you put them together, it'll be really easy. You'll be able to cancel out 7s. As you can see, the 7 on top will cancel with the 7 on the bottom. So we get the square root of 1 over 11. And we're going to split the root. The square root of 1 is just going to be 1, but the square root of 11, you can't break it down, but you can't leave it in the denominator. So once again, you have 1 on top, the square root of 11 on the bottom. To get rid of that square root of 11, you're going to have to multiply both top and bottom by that same square root value of 11. So up on top, you will get on your answer the square root of 11, and on the bottom, you will get just 11. There's your final answer for number 16. Number 17, if you think about putting them together, 3k over 8, that's a fraction that you cannot reduce, so there is no point in putting them together yet. But one thing that you could do is change that 8 and simplify it. So 8 is not a perfect square number, but what I'm going to do is rewrite the 8 as 4 times 2. That way I could split the root, and the square root of 4 is 2, and the square root of 2 will stay inside as square root of 2. On the top, we still have the square root of 3k. So this is our answer so far, but again, you cannot leave square roots in the denominator. So let's rewrite it. And let's also multiply both top and bottom by that exact square root value. So on the bottom, you're going to end up with this 2 times, what is the square root of 2 times square root of 2? That's just another 2. No more square root. And up on top, you could actually just multiply these and put them together underneath one square root. So we're going to put one square root, and we're actually going to multiply 3k times 2. 3k times 2 is 6k. So our final answer is the square root of 6k over 4. Number 18. If you look at the inside fraction, there's nothing that you could do. You can't reduce or anything. So I will split the root, and then I'm going to simply do each of these problems. Like the square root of 18, I could break that down to 9 times 2, and then split the root. So that will give me a 3 square root of 2 up on top. And then down here on the bottom, instead of x to the third, it's an odd power, so I'm going to rewrite it as x squared times x. And then I could actually split the root, and I will get, what's the square root of x squared? That's just x, and the square root of x, you're just going to leave it there. Now this is our answer so far. However, we cannot leave a radical in the denominator, so I will multiply both top and bottom by that same square root value of x. So our answer on top is 3, and of course square root of 2 times square root of x, that's the square root of 2x. And on the bottom, the square root of x times the square root of x, that's just x. Let's not forget about this blue x that we also have in the denominator answer. So our final answer is 3 square root of 2x over x squared. Number 19, we're going to split the root. Now, I want to do the numerator in red up here. I'm going to split the root. It'll be the square root of 4 and the square root of y. Now, the square root of 4, that answer is 2, and the square root of y is going to stay. On the bottom, I want to do this one in blue. When you split it, you're going to have the square root of 3 and the square root of y squared. And we should all know that the square root of y squared is y. So you really have the square root of 3 times y, and you want to put that y in front. So at the bottom, you're going to have y in the front and the square root of 3 right next to it. Now, again, this is your answer so far, but you can't leave a radical in the denominator, so you're going to multiply both top and bottom by the square root of 3. So when you're multiplying the square root of y times the square root of 3, that will be the square root of 3y up on top. Of course, we're going to take that 2 and put it out there in the front. And then we have y on the bottom times the square root of 3 times square root of 3, that's just 3. So our best answer would be 2 square root of 3y. Y times 3 is 3y. And that's it. Number 20. Before splitting the root and the root, before doing that, look at the fraction on the inside and simplify it in any way that you can. And I think we should know this from last week when we did exponents, the rules of exponents. When you have a over a divided by a cancels out. Now we do have 1b up on top and we have 4 on the bottom, so that 1b up on top cancels with one of these and you'll have 3 left over on the bottom. So what we really have on top is 9. So I'm going to rewrite the numerator in the fraction. What's left up on top? 9, and that's it. On the bottom, we're going to split the root. What do we have left? We have 4, and we also have b to the third on the bottom. So I hope we understand how we got here. And now from here, we're going to do the top. Square root of 9 is 3. And on the bottom, when I split it, I'm going to have the square root of 4, b squared times b. Now, why did I go b squared times b? Because b to the third is an odd power, so if you break it down as b squared times b, now you have an even power. You could actually do b squared. The square root of b squared is just b. The square root of 4 is just 2, and the square root of b just comes down. So this is your denominator. Let me put it up there. 2b square root of b. Now, of course, you cannot leave a square root in the denominator, so you're going to have to multiply both top and bottom by that square root of b value. So your answer is 3 square root of b over 2b, but then this b and this b becomes a single b. So I guess the final answer will be 3 square root of b over 2b squared.